Okay, another quick update to the driller project. As things stand, I've made a reasonable amount of progress since last time. Most of it around the FCL. So most of the relevant commands are now, or opcodes are now implemented. If you have a look at the script for the FCL interpreter, let's see there are implementations for all the relevant ones. Certainly the ones that affect the ability to play the puzzle aspect of the game through. So redraws, toggle visibilities, conditionals, that sort of thing are all in there. I've been testing this by running or duplicating a couple of playthroughs on YouTube of the Spectrum version to see if I can actually replicate the playthrough start to finish in terms of the puzzle aspect. Mostly there. There's a few more bits and pieces still to be solved, but getting there, and that's good. That'd be a good goal, is to actually achieve that point where I can play through the game without the drilling part, but the rest of the game, the puzzles, and get everything working. So that's almost there. The other aspect I've been working on is an override system. So the importing at the moment imports the Freescape database exactly as is. You can see in particular things like if we go to one of the scenes, such as Amethyst, which is the starting scene, it brings in all of the shapes, but it also brings in each of the materials on each of the sides and applies them separately. Now the reason that was done in Freescape was because obviously on the limited power of the machines at the time, there was no way that we could have real lighting. So any lighting effects or shading effects were applied manually by applying certain colours to different sides. On the Spectrum it was more evident by using grades of stipple pattern, shading pattern, going from very, very light to very dark. And when modelling the scene, you could choose a direction of the light, fake light, and just apply colours to each side to give the effect that light source was actually lighting your scene. In this remake, obviously we have much more control over that and real lights and shadows and so on, so it doesn't really make a lot of sense. But I do want to retain that ability to apply materials to each side of an object as it comes in, because it does play into some of the puzzles quite relevantly at later stages. So it's important to be able to maintain that, but override it where I want to. So thinking about trying to find ways to solve this problem, I came up with the idea of an override system. So where it loads in a JSON file that describes the Freescape database for each room, it now loads in, if we have a look at the room node, you can specify two different JSON files now. The first one is the main config, which comes from the Python script, which in turn converts from the binary dump from the Spectrum. And the second one is an override, which is a manually created JSON file. A simple example I've got loaded in here, which it's just a very simple dictionary with each key in the dictionary the name of an object. So quad 17, quad 18, cube 5 are referenced in here as overrides. I've got no overrides in there at the moment, but what this allows me to do is, during the processing of the scene, the room, is to give some hints to the code that's generating the data. A couple of key areas that I've implemented so far. I can implement all sorts of overrides here, but the most important ones I've implemented so far are things like the ability to control whether an object is collidable or not. So this one's an interesting one here. It's a pair of polygons, a pair of quads. Now, I mentioned in a previous update that because of the Z fighting issue on modern hardware, I had to resort to lifting the polygons a little to avoid conflict in the depth buffer and Z fighting, which works in most cases, but not all. But the side effect is it also increases the size of the collision volume for those simple polygons, which should be really flat and have no collision volume at all. In this case, because of the shift, the slight increase in size, you end up with a a collision volume that does actually have some depth, and you can see that when you play the game here on those two crosses in particular. If I walk up to them, although they appear to all intents and purposes flat to the ground, you do step up slightly when you hit them. It's not the end of the world, but it's something that I'd like to solve. And you can see here also this Z fighting issue, because they're two quads at exactly the same height, crossing over one another. It can't quite decide which one to light and render, so you get this Z fighting issue. So I'll explain another solution to that problem in a moment as well. So what I've done in the overrides is the ability to put in some flags in here. Hopefully I've got them still in the cut buffer. Yeah. So 2 flags in these two quads. One is to say no collision, and another is to hide mesh. I'll explain why the hide mesh in a moment. But the no collision thing, if you look over here, this is the node tree for the room, and these are the 2 quads. Each object that comes in from the Freescape database has a container node, which is either a spatial or a static body, if you understand some Godot terminology. And within that it contains various things, including collision shapes, the mesh itself, and anything else that's relevant. If you look at the flags or the parameters that you've got on this static body, it's a static body in this case, one of the things you have control over is these 2 areas here, collision layer and collision mask, and they define which objects can interact with one another in the physics engine. So the default layer is 1. All objects normally live on layer 1. The player object with its collision volumes can interact with objects on layer 1, and that's how the collision works and prevents you running through all the objects. If you move these things to a different layer, they won't interact with the player. The player is only looking for objects on layer 1. So what happens in the script now when it sees this no collision flag is it will move the object that it refers to a different layer. So it's no longer responding to collisions with the player. I've chosen 12 just arbitrarily, so it'll move it to 12. And the other thing this script does is it's got a hide mesh. Now this is to allow me to overcome the problem of the Z fighting. So what I need to be able to do is add a custom mesh in here that doesn't have the Z fighting issue. And that's quite difficult to do, because every time the script runs through at the moment is it wipes out all of the objects and rebuilds them from scratch. So what I've done is I've modified the script that if it sees any entry in here with the key for the object it's trying to create, and the object already exists in Godot, it won't delete it, but it will clear out its contents. So anything that's in here remains, and anything I've added will remain. So this is a custom mesh that I've just added manually. It just duplicates that, and I've got one on this one as well. So we've now got two rectangles in each one. And what you normally do is switch off the automatically generated one. The auto in both of these is the one that's created by the script. So now because I've modified this JSON file here, if I save that and rerun the import just by clicking this flag, you'll see it moves each object onto 12, each of these 2 onto layer 12, so the collision doesn't cause a problem anymore. It leaves my mesh, so it hasn't deleted that. Anything that I've created in here will persist, and it's also made the automatically generated mesh invisible as per this flag. So now if I play this level, you should see that we get our white cross now, which is the newly created one. We've got no Z fighting because I've overcome that within my custom created mesh, and more importantly, when you walk over it, you don't get that odd step. It just doesn't have any interaction at all. But the key is, because the FCL code exists up on this top level container node, that still works as normal. So if you click on these, they disappear exactly as they would have before, including hiding all of the custom details that I've added manually after. So that gives me the ability to start making wholesale changes to the collision and to meshes as well. So if I want to replace a mesh with something a little bit more interesting, or one that doesn't have the problems that you were seeing there with Z fighting and so on, I can do that. But the other thing that I want to be able to do is, as I said before, is modify these materials to something that makes more sense in a modern lighting enabled engine. So the way you do this in Godot is there's a number of different places you can apply materials to a 3D object. So a mesh instance is a node that contains a mesh. It's a simple node, but it has some stuff in it, including a reference to a mesh, which is a separate node itself. These are the things that are generated by the script, so you can apply materials to the mesh directly, which is what I do when I'm importing. So these are the materials that are loaded in from the material specifications in the Freescape database, and these are applied to each surface. The other place you can, or one of the other places you can place it, is on the mesh instance, and these will override. So if I was to place, I know slot 2 is the top, which is currently this cyan colour. If I apply a new spatial material here, it replaces that one. It overrides what's on the mesh. However, if I now rebuild the scene, that gets lost because the mesh instance is regenerated. If I apply that again and then set in here a flag instructing the script to keep the mesh instance instead of destroying it when it loads, then when I reload this scene now, the override is kept. Any changes to the mesh or to anything else will still be applied. So if the database changes or my Python script that interprets the database changes and produces different data, that will still be applied. If it becomes something other than a cube, for example, that will still be applied. But these overrides that I've applied into the mesh node will be retained. And more importantly, for this particular use case, there's a third place that you can override materials in Godot, and this is at the geometry level, which is a geometry instance, a parent node type for mesh instance, and you can have a single material override here. And this is, so if I add a spatial to this, it overrides all materials, both up through here and into here. So I can now apply a single material here and have complete control over it. And again, because it's on the mesh instance, if I go to here, reload the scene, that changes, it's persisted. So if I show again here, so I've got this object is pyramid 11. So if I apply a new material to this one and override, let's give it some color just to make it a bit more interesting. Yellow. Now if I were to reload the scene now, that would be lost. But if I just check it again, pyramid 11, so if I add to my script here a new entry that includes the keep mesh instruction, and then go back to Amethyst and reload it, it persists. So now when we play the scene, you get single color objects that are lit by the light, by the engine's lighting, which looks much more interesting. And when I add some decent lighting, it'll look much better. And similarly for the hut, it's now a nice single color, and I can apply all sorts of material effects if I want to for changing the surface properties and making it look a little bit more interesting, and retain them across reloads of the Freescape scene. So that's the overrides as it stands. I'll be developing that as I go through to make sure that it keeps the things that I need to keep and allows me to customize the Freescape scenes in a way that makes it look really good. A couple of other smaller things. You probably noticed that the controls have changed. They're no longer mouse to look around. They're much more aligned with the original Spectrum game. Left, right, look up, look down, move, back and forward, as per the original game. So in fact it's using exactly the same keys as the original Spectrum game, which will make it a little bit more fun to play. If you're familiar with the original game at least. And the other thing I've implemented now while I was working through the playthroughs is the switch between the probe and the jet. So these are the two vehicles that you can play with in Driller. This is currently the probe, which is like a tank-like vehicle fixed to the ground, just tumbles around wherever you look. You're continuously driving along the ground. And the other one is the jet, which you can get later in the game by going to a certain place and swapping to another vehicle. But to avoid having to go through all of that, I can show you very quickly just by going to the game settings and choose the start to be the jet. I hope. So hopefully now we can do things like fly up and move around much more freely. So I can actually get between locations a lot easier now just by flying off the side of one over the wall and appearing in the others. It gives you much more freedom to overcome some of the puzzles that are constrained by the probe vehicle and its fixed nature. That's why you don't get it till a bit later in the game. But that all seems to work and everything else is good. That's it for now. I'll do another update maybe next week, and hopefully we'll have something looking a little bit better with lots of new materials and a little bit more style to the rooms that isn't too garish. And I'm hoping this week to be able to get the puzzle completion finished.